What if the ticking of a clock isn't just a measure of seconds, but a doorway? What if every heartbeat, every sunrise, every fading memory is a thread in an invisible web, one that could be rewoven? For centuries, humanity has whispered the same forbidden question. Can we travel through time? From ancient temples to modern laboratories, from myth to mathematics, we've chased that question across the very fabric of existence. And perhaps, without knowing it, we already have. Time. It rules us, yet it hides from us. We live surrounded by its flow, an endless river carrying us from birth to death, and still we cannot touch it, cannot see where it begins or ends. It moves quietly, indifferent to joy or sorrow, and yet every human who has ever lived has felt its pulse within. Maybe that's why we dream of escaping it, of stepping beyond the current, because time, more than gravity or light, is the one true frontier that binds us all. We can move through space, we can cross oceans and planets, but we can never return to yesterday. Or can we? From the earliest civilizations, the idea of time travel was not merely fantasy, it was destiny. Ancient mythology spoke of gods who moved freely between past and future, of sages who remembered lives that hadn't yet been lived. In dusty temples and on star-etched stones, humanity left its first questions for the universe. What is time? And why does it never stop? Perhaps it was this mystery that gave birth to philosophy itself. When ancient thinkers looked at the stars, they didn't just see fire and light. They saw patterns, cycles, a cosmic heartbeat repeating endlessly. The moon waxed and waned, the seasons returned, rivers dried and flowed again. Everything, it seemed, was reborn. So why not us? Why not the moment we loved most? In every age, the dream of time travel carried a different name. The Greeks called it Chronos, the devourer of all things. The Hindus spoke of Kalachakra, the wheel of time, where the past and future are merely turns of the same eternal circle. In the north, the Norse saw it in the great tree Yggdrasil, whose roots and branches reached through every era at once. Time was never a line to them. It was alive, breathing, looping. And yet, while philosophers wondered, the scientists of later centuries would ask a deeper, sharper question. If time is part of the universe, can it be shaped like light or sound? Could we bend it or break it? But before equations, before Einstein and wormholes, before paradoxes and theories, came something simpler: awe. The kind that makes a child look at a sunset and feel that maybe, just maybe, the same moment is happening somewhere else again. That awe has followed us into every telescope we build, every particle we accelerate, every story we tell about stepping into the past or glimpsing the future. Because time travel is not just about movement, it's about meaning. It's about asking whether our choices are fixed, or if the universe itself still listens when we wish for one more chance. And so, as we begin this journey, we must ask ourselves, is time a prison we are trapped within, or a path we simply haven't yet learned to walk? Because if time is not a straight road but a vast circle, then every life, every dream, every forgotten civilization may still echo, waiting for someone brave enough to listen. Next, in the ancient legends of gods and heroes, we find the first travelers, not through space, but through eternity itself. Who were they, and what did they know about the secret nature of time? Long before science gave us formulas and theories, humanity looked to the heavens and saw time written in the stars. The ancients didn't just measure time, they felt it. Every sunrise was a rebirth, every eclipse a reminder that even the sky could forget its place. And in those moments of wonder, something extraordinary began to take root. The dream that time could be crossed, reversed, or even mastered. In the sacred texts of Egypt, time was not a line but a living being. The god He held the symbol of eternity in his hands, an infinite loop, the Shenu, wrapped around the universe itself. To the priests of Thebes, time was cyclical, breathing, and divine. They believed that through ritual, the past could be called back, that words and symbols could bend the order of creation. Each temple ceremony wasn't just remembrance. It was recreation, an act of traveling back to the dawn of existence to keep the cosmos alive. In India, the Vedic sages told of the Kalachakra, the wheel of time, where entire universes were born and destroyed within the blink of a cosmic eye. According to the Mahabharata, For the gods, what seemed like 1,000 human years could pass in a single afternoon. Time, they said, flowed differently in different realms. A mortal might meditate for a day and awaken to find centuries gone by. It wasn't fiction. It was revelation. A truth whispered from the heart of eternity itself. The same concept echoes in Buddhist philosophy. The Buddha spoke of infinite worlds coexisting within each moment. Entire histories layered like reflections on a still pond. Each life, each thought, each breath was a ripple, overlapping others, extending endlessly into the past and the future. To reach enlightenment was, in essence, to step outside the stream of time. Across the ocean, the Maya and Aztec civilizations carved time into stone. Their calendars were not just tools for counting days, they were engines of prophecy. Each cycle was believed to return, repeating cosmic patterns again and again. To them, history was not a march forward but a spiral, and the future had already happened, waiting to be remembered. In the glyphs of Chichen Itza and the pyramids of Teotihuacan, they captured an understanding of celestial cycles so precise that modern astronomers still marvel at their accuracy. But what inspired such obsession with the movements of time? Perhaps they weren't only marking days. Perhaps they were watching for the return of something ancient. And then, in Greece, the philosopher Heraclitus wrote, "The river we step into is not the same, yet it is always the same." To him, time was both change and permanence, destruction and renewal. The Orphic mysteries went further, teaching that souls were caught in an eternal loop of birth and rebirth, a cosmic wheel that only wisdom could escape. Meanwhile, far to the north, the Norse told of Yggdrasil, the world tree, whose roots touched the past and whose branches reached the future. The Norns, three shadowed figures, wove destiny into its bark, one shaping what has been, one guiding what is, and one forever writing what will come. They were, in essence, the guardians of temporal balance, the keepers of fate's threads. Even the Bible holds echoes of this ancient fascination. The book of Ecclesiastes muses, "What has been will be again, what has been done will be done again." The prophets dreamed of visions that came not from the present, but from times yet to unfold. And the apocryphal book of Enoch, once revered, later hidden, speaks of a man who walked with beings beyond time itself, learning secrets of the cosmos and returning changed. What unites all these stories is not coincidence, but longing, a universal desire to reach through the veil of now, to see what lies behind the curtain of time. Long before Einstein, long before clocks, the ancients whispered of bending time through prayer, trance, geometry, or sound. To them, time was never an enemy. It was a door, and for those who listened, priests, mystics, and dreamers, that door sometimes opened. Next, the world awakens to a new age, an age of invention and imagination. When literature and science merge, the impossible begins to look inevitable. The birth of modern time travel begins with a dream. The ancient world saw time as sacred, a living rhythm, cyclical and divine. But as empires rose and fell, the age of myth slowly gave way to the age of reason. The stars were no longer gods. They were worlds. The heavens were no longer mysteries. They were maps. And yet, even as humanity learned to measure time with gears and pendulums, it refused to stop dreaming of escaping it. The story of modern time travel doesn't begin with machines. It begins with imagination, with the writers and thinkers who dared to treat time not as fate, but as a landscape to explore. In the 19th century, the Industrial Revolution changed everything. Trains conquered distance, telegrams carried words faster than horses, and electricity began to blur the boundaries between the real and the impossible. The idea that human invention could reshape the laws of nature didn't just inspire progress. It awakened a new mythology: science fiction. In 1895, a quiet Englishman named H.G. Wells gave that mythology a heartbeat. His novel, The Time Machine, introduced the world to a nameless traveler, a man who steps into a brass and crystal vessel and vanishes into the fourth dimension. Wells didn't invent the dream of time travel, but he gave it a mechanism. For the first time, time was not merely divine will or cosmic rhythm. It was a road that could be navigated by human hands. The story electrified readers. The Victorians, surrounded by steam and science, felt they were already living in an age of miracles. If trains could break the limits of distance, why couldn't a machine break the limits of time? The idea spread like wildfire from literature into philosophy and soon into physics itself. At almost the same time, mathematicians were asking similar questions. The German scientist Hermann Minkowski proposed that space and time were not separate at all, but fused into one continuum, space-time. In this strange new vision, time was not an arrow but a coordinate, a dimension that could, at least in theory, be traversed. And from this seed of mathematics, a revolution was about to bloom. Wells' fiction and Minkowski's geometry converged in one mind, a young patent clerk from Switzerland named Albert Einstein. When Einstein read about time as the fourth dimension, he didn't see fantasy. He saw reality waiting to be understood. His special theory of relativity revealed that time was not absolute, could stretch, slow, or contract depending on speed. A clock on a fast-moving train would tick differently than one standing still. Suddenly, time itself was flexible, elastic, alive. But even before Einstein's equations shook the universe, poets and dreamers were already there. Writers like Jules Verne imagined cosmic voyages. Charles Dickens played with ghostly visions of the past and future. And philosophers pondered whether the soul itself might be a traveler through many incarnations. Every new discovery blurred the line between magic and science, myth and reality. The late 19th century became an era of mirrors. While physicists sketched formulas on paper, artists were sketching the same truths in prose and paint. Painters experimented with time and motion. Composers created music that folded back on itself, and inventors built devices that captured time's essence. The camera, the phonograph, the clockwork automaton. For the first time in history, humanity wasn't merely observing time. It was recording it. And then came the boldest idea of all, that perhaps the past never truly disappears. Every event, every heartbeat, every breath still exists somewhere in the continuum of space-time, frozen like light from distant stars. If one could move fast enough or bend the fabric of reality just right, perhaps one could step back into that frozen light and live it again. By the dawn of the 20th century, the dream of time travel was no longer confined to myth or metaphor. It had become a question for science to solve, a puzzle of mathematics and motion. But the closer we came to understanding time, the stranger it became. Because to bend time is to bend reality itself. And once you begin, there is no way to know where or when you might end up. Next, Einstein rewrites the universe. His theory of relativity opens the door to time distortion, and humanity begins to see that traveling through time might not be fantasy at all, but physics. At the dawn of the 20th century, the universe stood still, at least in our imagination. Time was a metronome, ticking evenly for all, untouched by speed or space. It was constant, unbending, universal. Then came Albert Einstein, and with a stroke of thought, he shattered eternity's symmetry. In 1905, Einstein unveiled his special theory of relativity. He was just 26, a clerk in a patent office, yet his equations rewrote the structure of reality itself. He proposed something astonishing: time is not absolute. It flows differently depending on motion. A moving clock ticks slower than one at rest. The faster you go, the slower time passes, until, at the speed of light, time itself stands still. It was a revelation that defied common sense. To imagine it, picture two twins. One boards a spacecraft and races among the stars at near light speed. The other remains on Earth. When the traveler returns, years, perhaps centuries, have passed for the twin who stayed behind, while the one who journeyed through space has barely aged. It was called the twin paradox, and though it sounded like fiction, the math was real. Relativity wasn't a story, it was a law of nature. Einstein's insight revealed that time and space are inseparable, forming a vast, woven fabric known as space-time. Mass and energy, he explained, bend this fabric. Planets curve it like marbles pressing into a cosmic sheet, and light itself follows those curves. We don't just live in time, we move through its folds. A few years later, Einstein completed his vision with the general theory of relativity. Gravity, he said, is not an invisible force pulling at objects. It's the shape of space-time itself, warped by mass. The sun curves the fabric around it, and the Earth simply follows that curve, endlessly falling around the star in what we call an orbit. In this model, time is not a constant flow but a malleable field, one that can stretch, twist, and slow. The consequences were staggering. A clock on a mountaintop ticks slightly faster than one by the sea. The heartbeat of time itself changes depending on where you stand. Even light, the fastest thing in existence, bends as it travels past stars. Einstein had turned the universe into a living sculpture, dynamic, curved, and mysterious. This wasn't just theory. Decades later, scientists proved time dilation using atomic clocks flown on airplanes. When compared to those left on Earth, the clocks in the air had ticked a few billionths of a second slower, exactly as relativity predicted. It was a tiny difference, but enough to confirm that time truly is elastic. Today, satellites in orbit must constantly adjust their onboard clocks for this effect, or GPS systems would drift wildly off course. Einstein's ideas aren't confined to chalkboards. They govern the precision of our daily lives. But relativity offered something more than accuracy. It offered possibility. If time could be stretched and slowed, could it also be reversed? Could space-time itself hold tunnels, shortcuts, or bridges between different moments? Einstein's equations didn't forbid it. Hidden within them was a haunting implication that the universe might contain natural pathways through time. Physicists began to dream of wormholes, hypothetical tunnels connecting distant points in space and time, folded together like the corners of a cosmic map. To travel through one would be to defy the arrow of causality itself, to leave the present and arrive in a different era. What was once myth had now entered the realm of mathematics. Einstein, ever cautious, smiled at these speculations but never dismissed them entirely. He understood that his discovery had opened a door that could never again be closed. Time, once thought to be rigid and eternal, was alive. A fabric that could be touched, distorted, and perhaps even crossed. For the first time in human history, science had caught up to myth. The gods of old who walked between ages might not have been fantasy, but the first metaphors for something deeper, a truth written into the universe itself. And yet, Einstein's theories raised a question that science still cannot answer. If time can bend, can it break? Next, we journey into the experiments that dared to test this cosmic fabric, through wormholes, black holes, and paradoxes that challenge the very meaning of cause and effect. What if the universe hides secret tunnels, bridges through time itself? Einstein's equations, mysterious and elegant, didn't just describe how the cosmos moves. They hinted at where it might fold. Inside those folds, some physicists believed, might lie the keys to time travel, the hidden doors of creation. It began with a thought experiment. Einstein and physicist Nathan Rosen proposed a strange solution to the equations of general relativity, a passage connecting two regions of spacetime. They called it a bridge. Today, we call it a wormhole. Imagine the universe as a vast sheet of paper. If you fold it, two distant points can suddenly touch. A tunnel between them, invisible, instantaneous, could allow a traveler to move from one end of the galaxy to another, or perhaps from one moment in time to another. To move through such a passage would be to step outside the normal flow of reality. It would not be flight through space, it would be motion through existence itself. But wormholes come with a problem. They are unstable, fragile structures that would collapse faster than light could cross them. To hold one open, scientists theorize we'd need exotic matter, a substance with negative energy, capable of defying gravity's pull. No one has ever found such material, but its possibility lingers at the edge of quantum physics, whispering that the impossible might still be waiting to be born. Meanwhile, another discovery was revealing that time behaves strangely in the most extreme places in the universe. Enter the black hole, a region where gravity grows so intense that even light cannot escape. Inside, time slows to a crawl. To an observer outside, a person falling toward the event horizon appears to freeze, suspended at the edge forever. But to the traveler, time continues normally, until the universe outside races ahead by centuries in a single heartbeat. It's not fantasy, it's relativity in motion. Physicist Kip Thorne once said that if you could orbit near a black hole, safely, impossibly close, hours for you might equal decades for someone far away. In that sense, black holes are natural time machines, bending reality through gravity alone. The universe, it seems, already knows how to manipulate time, we just haven't learned its language. To test these theories, scientists began to measure time with unimaginable precision. Atomic clocks were synchronized, flown on aircraft, and compared to their twins on the ground. When they returned, the airborne clocks had lost tiny fractions of a second, proof that time truly flows differently for objects in motion. Astronauts aboard the International Space Station age a little more slowly than those on Earth. Every orbit they complete is a microscopic leap into the future. And yet, for all this progress, something deeper remains unsolved: the paradoxes that haunt the very idea of time travel. If one could move backward in time, even for a moment, what would that mean for cause and effect? Could one change the past? Or would the universe rewrite itself to preserve its laws? These questions have no easy answers, but they lead to one undeniable truth. Time is not the silent, obedient force we once believed it to be. It bends, it loops, it whispers in equations and in starlight. The deeper we look into the cosmos, the more we see that every black hole, every spinning galaxy, every quantum vibration is part of a grand dance of time, a rhythm that connects the smallest atom to the farthest star. Modern physics stands at the edge of that mystery, peering into equations that border on poetry. Wormholes may yet remain theoretical, but they remind us that the universe is far stranger than any myth, and that perhaps myths were simply humanity's earliest attempts to describe truth science has only begun to measure. If time can twist around black holes and slow aboard spacecraft, what happens when it bends so far that it meets itself? Next, we explore the greatest puzzles of temporal logic, the paradoxes that defy both physics and philosophy. What happens when a traveler meets their own past? Can time itself protect its secrets? To travel through time is to challenge the deepest rule of the universe, that cause comes before effect, that every action leads to a consequence. But what if that order could be broken? What if an effect could reach back and shape its cause? This is the riddle at the heart of every time traveler's dream and nightmare. Einstein's equations never forbid moving through time, only make it unimaginably complex. But when mathematicians began exploring those equations, they found loops, strange, circular pathways in the fabric of spacetime where the past and future touch. Physicists call them closed time-like curves. In theory, they could allow you to return to a moment before you left it. But immediately, an ancient question arises: what happens if you change something once you're there? This is the essence of the grandfather paradox, the most famous riddle in the science of time. Imagine a traveler who journeys to the past and prevents their own ancestor from meeting the person who would one day become their parent. Without that meeting, the traveler could never be born. But if they were never born, who made the journey at all? It's a loop that collapses on itself, a contradiction that logic cannot contain. Physicist Stephen Hawking once proposed the chronology protection conjecture, suggesting that the universe may have built-in safeguards against such paradoxes. Reality, he said, protects the timeline. Perhaps every attempt to create a contradiction would simply fail. Events would adjust, subtly and perfectly, to preserve the flow of cause and effect. In that sense, the universe might be self-healing, rewriting itself to maintain balance. But not all scientists agree. Some, like physicist Igor Novikov, propose that paradoxes cannot exist, not because they are forbidden, but because time itself prevents them. In his self-consistency principle, every event in time, even one involving a traveler, must be part of a consistent history. If you travel to the past, you might witness your own arrival or even inspire it, but you could never change what already happened. Your actions, no matter how deliberate, would always align with the timeline's design. It's an elegant solution, but a haunting one. If true, it means fate is absolute. Even if you could walk through centuries, you would remain trapped inside destiny's architecture, unable to move even a single pebble from its place. You could visit the past, but never alter it. You could see the future, but never escape it. Yet other thinkers suggest a different possibility, that time might branch, splitting into new realities each time a choice is made. This idea, born from the quantum world, proposes that every decision, every possibility, creates a new universe where a different outcome occurs. In this view, time travel does not rewrite history, it simply creates another version of it. Kill your grandfather, and your own timeline remains untouched. You've only stepped into a universe where you never existed. It's elegant, terrifying, and strangely liberating. A cosmos of infinite versions of ourselves, all unfolding simultaneously. But these paradoxes are not just puzzles for physicists, they are mirrors for us. They force us to confront the question of who we are without the certainty of a single timeline. If every possibility exists, what defines you? If every choice creates another reality, is free will an illusion or the very essence of existence? From ancient myths of eternal return to modern theories of quantum branching, time has always resisted being tamed. It seems to bend just enough to let us glimpse its mystery, but never enough to let us hold it. The paradoxes are not flaws in our understanding. They are the fingerprints of a deeper order, one that may only make sense from outside of time itself. Maybe that's why time travel fascinates us so deeply, because in its riddles, we see our own reflection, fragile, curious, and forever reaching toward the impossible. For if time is a web, we are its threads. And perhaps every paradox is not a contradiction at all, but a reminder that the web is far more intricate than any of us can see. Next, from paradoxes to possibility, could humanity ever build a time machine? What technology, real or theoretical, might one day open the doorway Einstein only imagined? If time can bend, if it can slow, stretch, or twist, could it ever be shaped? Could a civilization one day hold the flow of centuries in its hands the way we hold light in a lens? This question has haunted scientists as deeply as it has poets. And though no one has yet traveled through time, physics whispers that perhaps, just perhaps, the door isn't locked, only unopened. To build a time machine, we would first need to understand time not as a current, but as a structure, something that can be curved by energy. Einstein showed us that gravity and motion distort time, and so our best hope lies in learning to manipulate those forces. The problem is not imagination, it's engineering the impossible. Some theorists begin with the wormhole, that ancient dream born from Einstein's own equations. If a tunnel through space-time could be stabilized, it might connect not just 2 points in space but 2 moments in time. Enter one side in the year 3000 and emerge from the other in 2025. In principle, the math works. In reality, it demands negative energy, a form of matter that repels instead of attracts, capable of holding the tunnel open against gravity's collapse. Quantum physics suggests such energy might exist in fleeting forms, observed in the Casimir effect, tiny forces measured between metal plates in a vacuum. If humanity could ever harness that power, a wormhole might not stay a dream. Others turn their attention to black holes and cosmic strings, natural engines of time distortion. A rotating black hole, according to the Kerr solution of relativity, could twist space-time around its center like a whirlpool, creating paths where time loops back on itself. In such a vortex, a traveler could, in theory, orbit inside a spiral of moments, stepping from one century to another with each revolution. But the price of entry is unimaginable. The gravitational pull would crush anything made of matter. For now, black holes remain silent teachers, showing us what's possible, but not yet what's survivable. Then there is the strange concept of the Tipler cylinder, proposed by physicist Frank J. Tipler in the 1970s. He imagined an object of infinite length, a colossal cylinder spinning at nearly the speed of light. Its rotation, he said, could drag space-time around it, creating a loop that allows travel into the past. It's a beautiful idea, but it demands materials and energies far beyond anything we can produce. Even if it could be built, its construction would require more mass than exists in the observable universe. Still, as thought experiments go, it proves one thing: the laws of physics allow time travel. They simply make it extremely difficult. Theoretical physicists like Kip Thorne, Carl Sagan, and Stephen Hawking often use such ideas not to promise time travel, but to test the boundaries of our understanding. Each thought experiment pushes science closer to the edge of metaphysics, forcing us to question what's truly forbidden and what's merely not yet achieved. And yet, not all theories rely on cosmic forces. Some look inward, toward the quantum world, where time behaves in ways that defy reason. Particles appear to influence one another across distance, even backward through time. In quantum entanglement, information seems to travel instantaneously, as though the universe itself is communicating between past and future. Could this be a glimpse of time's hidden infrastructure? A network that links every moment ever lived? Others speculate that consciousness itself might be the ultimate traveler. If the mind is not bound entirely by the brain, but by information encoded in the very fabric of reality, could thought, awareness, one day slip through time as easily as it does through memory? Perhaps déjà vu, those flashes of the future or the past, are not illusions, but echoes, the faint resonances of a timeless field we barely perceive. For now, these remain the musings of dreamers and physicists alike. But every age begins with what seems impossible. Before humans flew, flight was myth. Before space travel, the heavens were unreachable. And yet, the impossible has a habit of yielding to curiosity. The technology to build a time machine does not exist today, but the knowledge to imagine one that we already possess. Every breakthrough, every equation, every dream brings us closer to the realization that time is not a wall, but a wave. And waves, as we know, can be ridden. So perhaps the question is not if we will build a time machine, but when. Next, some say that time travel has already happened, that ordinary people have slipped through the cracks of time and returned to tell the tale. From mysterious photographs to vanished travelers, we uncover the stories that science cannot explain. For centuries, the dream of time travel belonged to philosophers and scientists. But sometimes the strangest evidence comes not from laboratories, but from life itself. There are stories whispered, documented, dismissed, of ordinary people who vanished from one era and appeared in another. Their accounts defy logic, yet persist through history, as though time occasionally opens its eyes and lets someone slip through. One of the earliest modern tales comes from Versailles, France, in the summer of 1901. Two schoolteachers, Charlotte and Moberly and Eleanor Jourdain, visited the gardens of the Petit Trianon, once the private retreat of Queen Marie Antoinette. As they wandered, the air seemed to grow still, heavy, unreal. They claimed the light itself changed, soft, greenish, dreamlike. Then, ahead on the path, they saw people in 18th century clothing. Men in powdered wigs, women with parasols, a young noblewoman sketching quietly by a fountain. Moments later, everything faded. The air cleared. The sounds of modern Versailles returned. Years later, they identified the woman in their vision as Marie Antoinette herself. Skeptics called it imagination. Others wondered if the two women had somehow walked into a temporal echo, a memory of the past still imprinted on that place. Another story, stranger still, surfaced in Spain in 1950. A man named Rudolph Fentz was reportedly found wandering aimlessly in Times Square, New York. He wore 19th century clothes, carried obsolete coins, and possessed identification papers dated 1876. Moments after being questioned, he was struck by a car and killed. When police traced the name, they discovered that a man with identical details had vanished in 1876, without a trace. The tale was later traced to fiction, or was it? Some insist the legend was based on a true event, now blurred by retellings. A story that refuses to vanish from time's memory. In 2000, an internet user identifying himself as John Titor appeared on online forums, claiming to be a soldier from the year 2036. He described the future in haunting detail: political divisions, global unrest, and technologies yet to exist. Most dismissed him as a hoax, but as the years passed, a few of his predictions, quantum computing breakthroughs, microcivil networks, even hints of social fragmentation, seemed to mirror reality. Titor vanished from the internet as suddenly as he arrived. No trace, no explanation, just digital footprints fading into the void of cyberspace, like echoes from a future we haven't yet reached. But these aren't isolated stories. All over the world, similar accounts emerge. fleeting, impossible moments that challenge the boundaries of reason. In Scotland, a hiker reported seeing a Roman legion marching silently through the mist, their feet sinking below the floor as though walking on a buried road. In Japan, a woman allegedly fell asleep on a train in 1933 and awoke decades later, still wearing the same clothes, her memory of the journey unbroken. In Argentina, two men claim to have driven into a blinding fog in 1969 and emerged onto a road filled with cars from the 1930s. They spoke briefly with people who stared in confusion. Then the fog returned, and they were back in their own time. Science cannot prove these stories, yet it cannot fully dismiss them either. Modern physics accepts that time and space are interwoven, that gravitational fields can bend the flow of moments. What if certain places, under certain conditions, act like natural lenses, bending not light but time itself? Could intense magnetic fields, tectonic pressures, or energy anomalies create fleeting doorways between now and then? Some researchers call them time slips, moments when parallel timelines brush against each other, producing glimpses of the past or future that fade as quickly as they appear. Across cultures, similar ideas exist under different names. The Irish spoke of thin places, where the veil between worlds grows transparent. In Hindu lore, sages entered meditation so deep they awoke centuries later. The Aboriginal Dreamtime of Australia speaks of a realm where all times coexist, the eternal present behind the illusion of change. Perhaps these weren't metaphors at all, but ways to describe what science is only beginning to glimpse. And maybe, just maybe, these stories are not mistakes of perception, but invitations to reconsider what now truly means. Perhaps time doesn't flow like a river at all. Perhaps it's an ocean. And sometimes, when the current shifts, a few souls drift into another tide. Next, if time travel were real, if we could truly step beyond the present, what would it mean for our understanding of fate, memory, and free will? The next chapter asks not how we could travel through time, but why we might choose to. If humanity could travel through time, what would it truly gain? Would we master the universe, or discover that we were never its masters at all? Because behind every question of how time travel might work lies a deeper, quieter question. Why would we want to? From the first myths of eternal return to the equations of Einstein, we have chased time as though it were running from us. Yet maybe time has never moved at all. Maybe it is we who move, tiny sparks drifting through an ocean of moments that already exist. Every past, every future, already written, already waiting, like stars forever burning beyond the night we can see. If that is true, then to travel through time is not to change history, but to visit its endless rooms. And in those rooms lie our choices, our regrets, our triumphs, each frozen, complete. Imagine stepping into your own past, seeing yourself as you were, hearing the echoes of decisions that made you who you are. Would you reach out to change them, or would you finally understand them? Philosophers have long debated whether time is linear, circular, or something even stranger, a pattern beyond geometry. The ancient Stoics believed everything repeats eternally, that the universe cycles through identical ages again and again. In that view, we have already lived this moment infinite times, and will live it infinite times more. To act nobly, then, is to choose the same virtue forever. To love, to forgive, to learn, each is an echo that reverberates across eternity. Others see time as a grand illusion, a trick of perception. In the 20th century, Einstein himself wrote, "The distinction between past, present, and future is only a stubbornly persistent illusion." According to relativity, all moments coexist. The birth of the stars, the fall of Rome, your next heartbeat, each suspended in the same timeless fabric. We perceive motion because our consciousness travels through this landscape one frame at a time, like a lantern moving through a frozen film. So what, then, is time travel? Maybe it is simply learning to move that lantern differently. And yet, our hearts resist the idea that everything is fixed. We feel destiny tug at us, but we also feel choice, the strange freedom to shape what comes next. If we could step into the future, would we dare? Could we bear the knowledge of what's to come? Every victory, every loss, already inscribed in the tapestry of time. Would seeing it change anything? Or would it trap us, turning wonder into inevitability? The possibility of time travel invites not only adventure but humility. It forces us to confront the nature of existence itself. If time is a landscape, then life is not a race from beginning to end. It is an act of navigation. Every thought, every emotion, every moment of compassion might ripple across the centuries. What we do today may already be echoing in the past, shaping the world we think we left behind. Many philosophers, from Augustine to Heidegger, spoke of time not as a physical phenomenon, but as a dimension of being. To exist is to unfold in time. Without it, we could not grow, change, or even remember. Time is the stage on which consciousness becomes self-aware. To master it may be the same as mastering ourselves. But perhaps time travel, if it ever becomes possible, will not begin with machines. Perhaps it will begin with mind, with understanding. To travel through time might simply mean learning to perceive beyond sequence, to see cause and effect as a single luminous whole. Mystics have described this for millennia, the moment of enlightenment when all times converge, when the self expands beyond the clock. To them, timelessness was not an escape from life, but the ultimate participation in it. So maybe the dream of time travel isn't about escaping the present. It's about seeing it clearly. Because in every second, past and future already meet. Every choice you make today is a portal, a branching path where worlds are born. And in that sense, we are all time travelers, shaping eternity one heartbeat at a time. Next, in our final chapter, we step beyond science, beyond myth, into the mystery itself. Is time travel humanity's greatest illusion, or its ultimate destiny? The answer may lie not in equations, but in the nature of time itself. Time. It is the one thing that touches everything, the silent sculptor of worlds, the pulse behind every heartbeat, the invisible current that carries galaxies across eternity. We have measured it, feared it, worshipped it, and tried to outrun it. And yet, the more we chase it, the more it seems to dissolve in our hands, like mist touched by light. Throughout this journey, we have seen how time transcends every boundary, from myth to mathematics, from prophecy to physics. Ancient priests carved its rhythms into stone. Philosophers described its cycles as mirrors of the soul. Scientists bent it with gravity and motion, proving that even seconds can stretch and slow. And dreamers, from H.G. Wells to Einstein to those who glimpse impossible moments, have kept asking the same question. What if time is not a prison, but a path? Perhaps time travel, as we imagine it, the leap through centuries, the machine of brass and light, will forever remain a dream. But maybe the dream itself is the real technology, waiting to be understood. Every vision begins as imagination. Every discovery begins as wonder. And every act of curiosity is, in its own way, a step beyond time, a bridge from what is to what could be. In the deepest sense, we are already travelers. Our minds wander constantly between past and future. We remember, we anticipate, we relive, we rewrite. Each memory is a visit to a world that no longer exists. Each hope is a journey to one that has not yet arrived. Our consciousness, flowing freely through the continuum of experience, might already be the universe's first and oldest time machine. Modern physics suggests that the universe may not distinguish between what has happened and what will happen, that all of time exists at once, like pages bound in the same eternal book. If so, then our lives are not lines but sentences written across dimensions, each word affecting the next. To understand time, perhaps we must first learn to read that book, not with our eyes but with our awareness. And if time travel one day becomes possible, would it be an escape or a revelation? Would we use it to correct our mistakes or to finally understand them? Would we visit the past to change history or to see that history has always been changing us? The answers may not lie in laboratories or equations, but in how we perceive existence itself. Maybe the ultimate lesson of time travel is not about movement, but meaning. Not about controlling the universe, but realizing we are part of its timeless design. Because whether we stand in the temples of Egypt, the observatories of modern science, or the quiet corridors of our own thoughts, one truth endures. We are creatures made of time, and yet we are also its witnesses, aware, curious, eternal. So, is time travel a myth or the science of the future? Perhaps it is both. A myth that science is slowly remembering, a truth too vast to fit into a single era. The ancients saw it in the turning of the heavens. Physicists see it in the bending of light. Two languages, one mystery. Maybe one day, far beyond our century, a human being will step into a machine, touch a switch and vanish into another age. Or maybe it has already happened, and we are living in the echoes of that first impossible journey. Until then, the mystery endures, not in the machinery of physics, but in the heart of every human being who has ever looked at a sunset and wondered where the light goes when it fades. Because perhaps the real question has never been, can we travel through time? But rather, are we already doing it every moment we exist?